When I was young, radioactivity was a word that was synonymous with Superman, the Incredible Hulk, and a bit later, radioactive man. For me, radioactivity didn't have a solid definition. It was merely a mystical source of untold supernatural human powers and grotesque mutations. Even in elementary school, my understanding of radioactivity still remained, at best, rudimentary. At that stage, radioactivity only existed in the nuclear waste produced by nuclear power plants and, to an extent, in my fantastical dreams. In short, radioactivity was just another buzzword used by kids during recess in the playground and role-playing games to express various superpowers. I like to think that when I entered high school, my perception and understanding of scientific concepts grew. Indeed, this was the time when my interest in science really began to burgeon. In my free time, you would probably find me hidden deep within a copy of New Scientist or National Geographic. Even then, from what I could glean, radioactivity was no more than unstable particles that broke down, emitting energy in the process, and somehow associated with a funny device called a Geiger counter that made clicking noises when it detected radiation. But the fact was, this idea of radioactivity didn't appeal to me in the same manner that evolution and chemical reactions had taken off. In my mind, I think it's because I couldn't physically see how and why radioactivity functioned the way it did. I was merely presented with what happened, something I wasn't really fascinated by. My lack of passion and ignorance, if one may call it, for radioactivity made a surprising turnaround during my time in Physics 102. No, I didn't fall in love with radioactive decay equations. That's old school. Rather, what really won me over were those few sections at the back of my beloved physics textbook that discuss the implications of radioactivity and how we have employed radioactivity for use in modern society, such as with radioactive carbon dating to determine the age of organic material, medical tracings with iodine-131 to determine malfunctions of the thyroid gland, and capturing nuclear energy through uranium fission reactions. Although some people may take these processes in stride, for some peculiar reason, the ideas and innovative techniques involved in radioactive technology has really baffled me. Perhaps I should clarify my bafflement with an example. Whereas I used to simply sit back and stare blankly around the room as my dentist took x-rays of my teeth, I now ponder how x-rays work. How did anyone conceive the technology for x-rays? How did people demystify the complexities of using the proper radioactive elements for safe medical x-rays? Etc., and so forth. In fact, the radioactivity section of Physics 102 has really forced me to change my perception and frame of mind, to really think beyond our macroscopic world and delve into how and why things work the way they do at a microscopic level. In the same sense, I have developed quite a bit of respect for the countless individuals who have become iconic figures in the field of radioactive physics. Sometimes, I just have to stop in appreciation for how much they've contributed, especially since their knowledge in their time was incomplete. I guess these individuals just epitomize the versatility, creativity, and ingenuity that comes with the human mind. All I can say for sure is that they are some pretty interesting and inspiring people. So how has my perspective on radioactivity changed? I can't say I'm madly smitten with radioactivity, but I can say it has helped me think about concepts from a different angle, not just in physics, but in pretty much all my other courses as well, even outside of the classroom. As a rapidly developing area of study, radioactivity has enormous potential to make advances, something I just might consider being part of if my interest continues to grow in that direction. For now, I'll just have to be content with a careful balance between dreaming of my childhood radioactive superheroes and preparing for the Physics 102 final exam.